Welcome to Business Math. It happens to be January 10th. We're going to go into Chapter 3 today, unless you have any questions that you would like to ask about Chapters 1 or 2. Percent is what we're going to talk about. Today we're going to convert decimals to percent, and percents to decimals, and fractions to percent, and we're even going to convert percents into fractions. So sometimes we don't do that one as often, but that's what we're going to do today. So let's go ahead and get started. For starters, it's very important that you know what percent means. In fact, that's more important actually than even all the conversions and all the techniques, because if you really don't know what percent means, then all of that calculation stuff is really kind of meaningless. So when we write something like 37%, that's of course the sign that we use, but it means 37 if you write it out per cent. Cent means 100, so 37 per 100, that's what it means, or 37 out of 100. So that's what 37% means. So a lot of times when I'm teaching a personal finance class, for example, I'll end up asking, well, what's 37% of $100,000? And then someone will say, I don't know what that is, or let me grab a calculator. And so then I will go on my, let me get the eraser here and erase the rest of this. Whoops. Erase. Then I will go on my rant of, well, what's 37% of 100 dump trucks? 30% of, I'll just say 100 trucks. Room. So what is 37% of 100 trucks? Rachel.
Just a moment, I'm getting it for you. Yeah. It's 37.
It's 37 trucks. And then I go 30% of 100 bananas. And 37% of 100 bananas is how many bananas, Courtney?
37.
37 bananas. And then I go 37% of 100 monkeys is how many monkeys, Robert?
37.
37 monkeys. And then I go, oh, okay, so what's 30% of 100,000? And the answer is what, Jonte?
37.
30, and then don't forget to do the label, 37,000. See? So the answer to this one way up here is 37, but you got the label, 37,000. So 37% of 100 million. 37% of 100 million is how much? Wyatt.
That's on already.
37 million?
37 million. See, the idea is, if you've got 100 million, the easiest way to think about this is think of million as a label. 37% of 100 million is 37 million. And in fact, even to get try to get real graphic. Let's get real graphic. All right. Let's clear this ink layer. And if we draw a 10 by 10 square, we're going to have to pretend I can do this well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's not too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have to pretend that's good. So 37% graphically, this is a 10 by 10 square. How many squares should I color in, Shay?
37.
37 squares. That's exactly right. So, if I'm going to color in 37 squares, well, there's 10 squares, there 20 squares, there 30 squares, and then color in 7. 1, 2, 3, 4, 5, 6, 7. There you go, 37%. That's a visual. And it is extremely important that you know what percent means. Because really what it is, it's a ratio. It's a ratio that's the same thing. In fact, if you were going to write 37 as a fraction, how do you write 37 as a fraction? Let's go back to Courtney.
37 over 100.
Excellent. 37 over 100. Because we're talking about 37 per cent, 37 per 100, 37 out of 100. The ratio, 37 to 100. In fact, sometimes they write ratios like this, 37 colon 100. So the fraction 37 over 100, that is the same thing as 37%. So then, visually, you should be able to answer all kinds of questions. For example, is 37% less than half, or is it greater than half? What do you think, John Tay?
Less than half.
Yes, it is. It's less than half. You can see it's 50 out of 100 would be half, wouldn't it? So there are certain percentages, for example, that you should be very familiar with. For example, 50%. In a reduced down fraction, what is 50%? If you reduce the fraction all the way down, Robert, reduce that fraction all the way down. 50 over 100, reduce the fraction.
1/2.
1/2. So that's one of the most common percentages there is. Another common percentage is 25%. What fraction is that equal to, Rachel?
It's 25 over 100 or 1/4.
Excellent. So that is 25 over 100, and if you reduce it down, we can divide numerator and denominator by 25, and so it reduces down to 1/4. 75% is another very common percentage, and in fact, that is also a very common fraction. Shay, what fraction is that?
3/4.
Yep, 3/4. So these are real common ones that hopefully you don't have to do any calculations on. Some other common ones. Here's some more common ones that hopefully you don't have to do any calculations. When somebody says, oh, you should be able to go in both directions. 1/3 or 2/3 as percent. Do you know what percent 1/3 is? Wyatt?
33.
Yep. It's actually, and if you really want to be accurate, it's 33 1/3%, isn't it? Now, in fact, most of you probably already know this, and hopefully I'm just boring you out of your trees. But when you, to convert a fraction into percent, you divide, don't you? So you get 3 there, 9 there, 1 there, 10 there, 3 there, 9 there, 1 there, and it just keeps going and going and going and going, doesn't it? So that's the reason why a lot of times we'll stop right there, we'll take the remainder over 3, and it will say 33 1/3%, okay? 2/3 is what as a percent, Courtney?
15%.
15% is a good guess. You get 2 points for your good participation. Wyatt, what do you think 2/3 is?
66 and 0.66.
Yes. So when we say 66 2/3%. Because if you take 2 divided by 3, and you end up getting 6 there, 3 times 6 is 18. Subtract, you get 2, bring down the 0, you get 6 again, 3 times 6, 18. Subtract, you get 2 again. So it's 0.66 2/3, or in other words, 66 2/3%. So these are very common fractions and percents that you should be familiar with. Also, the other fractions that you should be, and percents, that you should be able to turn into percents or fractions either way: 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, 90%, and 100%. So let's start with 10%. What fraction is that, Shay?
And over 100.
Very good, 10 over 100. And then we reduce that down. So what does that reduce down to, Shay?
1 over 10.
Excellent. 1 over 10. And then 20%. What fraction is that, Rachel?
$20 over 100.
Very good. And then reduce that for us, Rachel.
It's 1/5.
Very good. 1/5. Because 20 goes into there once, 20 goes into there 5 times. So 30% is what fraction, Robert?
3 over 10.
Yeah, it's 30 over 100, which is 3 over 10. 40% is what fraction, Jonte?
40 over 10.
40 over 10, and then what percent, what fraction does that reduce down to, Jonte?
2/5.
Very good, 2/5. And 50% is what fraction, Jonte?
50%, 50 over 100.
Yep, 50 over 100, and then reduce that down, please.
1/2.
1/2. So, now let's see how fast we can just rip through these. 60%. What fraction is that, Robert?
3/5.
3/5. Very good. 70%. What fraction, Rachel?
7 over 10.
Very good. 7/10. 80%. What fraction, Shay?
8 over 10.
8 over 10. And then reduce that down for us, Shay, please. 4/5. Very good. 4/5. 90% is what fraction, Wyatt?
9/10.
9/10. And 100% is what fraction, Courtney?
1.
1 over 1, which is 1. Now, so, you know how to convert decimals to percents. We went over that. Maybe you probably should go over that a little bit more. Make sure you know how to change a decimal into a percent. Let's see. If I have a decimal, 0.14 0.4693. How do you convert that into a decimal? Jonte?
You go to your calculator, then you hit math, and then you get two in terms of.
You can, but that's a lot of work. And I'm lazy. I don't like work.
That's the way
So
I
what?
do it.
That's how you do it. Well, I'll give you 2 points for that. Courtney, do you know the shortcut way to change that into a percent?
Move the decimal place to the
And you move it which way, Courtney, left or right?
right.
Excellent. Because, see, we're really multiplying by 100, aren't we? So to convert a decimal into a percent, you multiply by 100. And so that will change that decimal, 0.14693, into a percent. That'll change that into a percent. So, let's try another one. 0.3917. Change that into a percent, Jonte.
It is 39.17.
There you go. 39.17%. That's it. And that is a lot faster than grabbing your calculator. Okay? Now, let's change something more difficult into a percent. Once in a while, when we're doing percent of increase, by the way, let me go over this. Percent of increase and percent of decrease. Percent of increase. I think somebody's going to have to turn down the heat in Alva. So do we have a facilitator over there?
Yeah, I'll just mute the
Yeah.
microphone while it's going.
Oh, there you go. So percent of increase, it's the increase divided by the basis. Increase divided by the basis. So when we have in stocks, for example, when we have a stock, and this actually happened, where stocks would actually increase, they would go from 8 cents all the way to $841 a share. We actually had stocks that did this especially during the dot-com boom. So to figure out this percentage, I'll tell you what, I don't want you to get lost in the figures right now. So I'm going to say that it increased from 8 cents to $841.08, right? Now, the way you do percent of increase is you take the increase divided by the basis. Now, the basis is what you start at. That's what you start at, the basis. So it starts at 8 cents. So we know what goes in the denominator, Wyatt?
8 cents.
The 8 cents. That's what goes in the denominator because that is what we're starting at. So that is the basis. So the basis always goes in the denominator. And the good news is this is true for both percent of increase and percent of decrease. And by the way, I feel sorry for y'all because I actually enjoy this. It's not even fair, is it? Rachel, that's not fair.
Not at all.
Not
at all.
Not at all. It's totally unfair. Especially, I'm the one that gets paid to do this, and I enjoy this. There's something wrong about that. Okay. Now the increase, we're going to have to subtract these two to find the increase. So, what is the increase between 8 cents and $841.08? Shay, what's the increase? Just go ahead and subtract the two. There you go, $841. Now you got to grab your handy-dandy calculator. By the way, what's the name of my facilitator in Alva?
Connor?
Connor, you're doing an awesome job. I really appreciate you. 841 divided by 0.08. Let's see. Let's get the handy-dandy calculator out. Oh, Rachel, do you have your calculator handy?
Yes, sir, I do.
And with my ancient cell phone that's a year and a half old, I have to wait for my home screen to come up. But what did you get when you took 841 divided by 0.08?
$10,512.50.
$10,512.50. Yeah. So, you take the 841 divided by the 0.08. Then I asked if this were a problem in personal finance, I would say, all right, convert that 10,512.5, convert that into a percent. And invariably people say, well, that's 105%. Or they'll say something else. But remember, this is one of our problem-solving strategies. Go back to an easier problem. And how do you change 0.7 into percent? How do you change 0.7 into percent? Robert, you know.
Decimal 2 places, right?
Decimal point, 2 places to the right, so you get 37%. So now, Wyatt, change that 10,512.5 into percent.
Replace the 11.
I want you to change this into a percent.
I'm not sure here.
Well, let's review. Let's come back down here. I shouldn't even erase that for you. 0.37. Wyatt, change that into a percent.
37.
37%. And here's what we did. See, we take a look at an easier problem. This is good problem-solving strategy. It should be in your notebook. We move it 2 decimal points to the right, because we're actually multiplying by 100. When we move it 2 decimal points to the right, the decimal point lands right there, so we get 37%. So, Wyatt, what do I do with this decimal point right there?
Replace the 11. How'd you? Does it would go to the right?
You're correct. It goes to the right. Because when you multiply by 100, it goes to the right. See, that's why I gave you such a hard problem. But this is a very realistic problem. This happens in stocks, and it's happened actually a lot during the dot-com era. An 8-cent stock would turn into $841. And you would end up with a percent of 1.05125%. In other words, you would end up with a 1,000,000% increase. And this actually happened during the dot-com era. I actually shook the hand of a couple of young men way back when. They bought Yahoo when it was about 8 cents. And it went all the way up to something like $300 a share. And they took $10,000 that their grandpa gave them, and they invested it when Yahoo was about 8 cents. And both of them became multimillionaires. Pretty neat. I shook their hand right there. Shook hands with millionaires. I shook hands with a billionaire once. Harold Hamm, you know that? He's a billionaire. I shook hands with Bill Clinton, too. Of course, I immediately washed it afterwards, but I was a little Bill Clinton humor there. See, Rachel, you're the only one that gets the extra credit. Right there. All right. Well, anyway, you move the decimal point 2 places to the right. And it almost sounds ridiculous to get a 1,000,000% increase. But that's exactly what happened during the dot-com era with some stocks. So, to review, percent of increase, it's increase divided by the basis. How do you find the increase? Wyatt? How do you find the increase? I say increase divided by basis. How do you find the increase?
Just subtract the basis.
Bingo! You take the basis and subtract it from the final price of the stock, whatever it increased to. So you just subtract these two, and that's the basis. Now, how do you know which one is the basis? Rachel, how do you know which one is the basis?
What's behind the decimal point?
That's a good guess. Robert, what's your answer for how do you know which one the basis is?
What you start with.
What you start with. That's the basis. It's what you start with. Now let's do a percent of decrease. A percent of decrease. We're going to do percent of decrease with some financial stocks that crashed from... Oh, that's fascinating. I guess I can get a new one. We're going to do a percent of decrease with some financial stocks during the latest Great Recession. Percent of decrease. All right. Good news is it's the decrease divided by the basis. Decrease divided by the basis. All right. So let me give you a dot-com stock. Oh, I'll give you Bear Stearns. Now, Bear Stearns eventually went to zero. But we'll just say I'll capture a moment in time before Bear Stearns went to zero. And Bear Stearns, I believe, was about $182 a share. Okay? In fact, we're going to say $182.13 a share. And it just crashed all the way down to 13 cents. Okay? Eventually it went to zero. But right now we're going to do percent of decrease. Okay? Now the good news is the basis is what you start at. So, which one is the basis? The $182.13 or the 13 cents? Shay.
182.13.
There, very good. So the 182.13 is the basis because that is what you started at. So there's the basis right there. That's what you started at, 182.13. Now, take a guess at how you find the decrease. Robert.
182.13 minus 13 cents.
Very good. So the decrease, you just subtract them again. So you get $182 is the decrease. All right, grab your handy-dandy calculator. Let's see, Wyatt, can you do this one for us, please? So what'd you get?
.999.
2, 8 and a bunch, right? That's what I got.
Yeah.
Is that what you got?
Yeah.
So let's just round it and put a 3 there. How's that? Because the 8 is bigger, is 5 or larger, so we'll go with 0.9993. So change that to a percent for us. Dante.
99.93%.
Now, Jonte, did you do that one correctly? You moved the decimal point 2 places to the right. Should you have moved it 2 places to the right or 2 places to the left?
To the right.
Oh, I was trying to trick you, Jonte, and I did. That's not nice to trick anybody before 9 o'clock in the morning, is it? That is not nice at all. I'm glad I didn't trick you. You do move it to the right. 99.93% decrease. That was the decrease. By the way, some people like to put a negative sign here. I don't really care. Some people like to put a negative sign there. Some people like to say negative 99.93% to remind us that it is a percent of decrease. I really don't mind. If we say percent of decrease, then 99.93%, we know that it went down, right? Oh, by the way, what's the largest percent of decrease you can get? The largest percent of decrease you can get, Rachel?
100%.
100%. And that's exactly what Bear Stearns did. It went to 0. Just like GM. GM stock went from like $65 a share all the way to 0. So a neighbor friend of mine, he had quite a bit of GM stock. He lost 100% of his stock when GM went bankrupt. Even when the government took it over, he didn't get any money from his GM stock, okay? It had a 100% decrease. Now, he also had some GM bonds. The GM bonds had a 90% decrease. They didn't go to 0. So let's see how much my neighbor lost on his GM bond. My neighbor had $150,000 of GM bonds. The GM bonds had a percent of decrease of 90%. So the question is, you could answer it in one of 2 ways. You could say, how much did he lose? Or how much did he have left? Oh, let's just say how much he had left. Out of the $150,000, how much did he have left since he lost 90% of his GM bonds? Let's go to Robert. Very good. And then you can subtract that from 150. Now, this is what's really cool if you understand percents. If he lost 90%, what percent did he have left, Robert?
10.
He had 10% left. And if you happen to be a person that tithes on your income, you know how to do 10% real easily, don't you? You just lop off a 0 because you're dividing by 10. So he had left $15,000. Now you can double check your answer. You can do it like Robert said. Take the 90% times 150,000, subtract it from 150,000. You'll end up getting the same thing as 15,000. That's where it's really nice to understand percents. My wife understands percents pretty well because she is an avid shopper. And so she knows percents per QL. She can compute, those sales. She is pretty awesome at calculating percents. So if somebody has a gigantic sale, and let's say this gorgeous blouse costs $80. This gorgeous blouse costs $80. $79.95, but hey, let's just round it. And let's say it's a 70% off sale. Okay? Because maybe it's a winter blouse. It's starting to put out the summer blouses. So a 70% off sale is the same thing that you're going to pay what percent, Shay? If it's 70% off, that means you're going to pay what percent? 30%. So if it's a 70% off sale, it means you're going to pay 30% of the price. Now, you should know how to do 10% very easily in your head. Because 10% of 80, what is 10% of 80, Rachel? I'll give you a hint. Just lop off the zero. 10% of 80. 10% of 80 is what?
$8.
$8. And you're going to do 30%. So 3 times 8 is how much, Wyatt?
24.
$24. So my wife knows she's going to be able to buy this blouse for $24. That's going to be the sale price of the blouse. She's pretty good at this in-your-head stuff because she shops so much. I love my wife to pieces. So she's pretty good at this. When she sees a 70% off sale, she goes, I know I'm only going to pay 30%. Move the decimal point over one place to do 10% of a number, $8, 3 times 8, $24. So she's a pretty good shopper. She can do all that stuff. All right. Well, rounding percents. We did a little bit of that already. This is page 70 and 71. I'm not going to read that to you. You need to read it yourself. Percents into decimals. We did some of that. We need to do a real tricky one. A real tricky percent into decimal. Let's say that we have a 0.04% chance. We'll talk more about probability later. See, I'm thinking back to college when I had a 0.04% chance of dating this absolutely gorgeous girl. Brings back memories. Change that into a decimal for me. Shay, how do you change that into a decimal? Oh, is that your final answer?
Yes.
Well, you get 2 points for your good participation. Because when we change 0.04 to percent, we multiply by 100 and we get 4%. But when we change a percent into a decimal, which way do we move the decimal point, Robert? Left. So you have to move the decimal point 2 places to the left. So you're going to get 0.0001. 4. So that was my actual probability of dating that gorgeous girl. Which she was shallow anyway, and so I ended up marrying my wonderful wife of 42.5 years. But that's how you change probability, well, percent, into a decimal point. Move the decimal point 2 places to the left, because you're actually dividing by 100. Because this right here, that percent, means divide by 100. See, per 100. So if you're going to divide that by 100, you move the decimal point from there 2 places to the left. So that's the reason why you get the 0.0004. So I told you that was a tricky one, didn't I? So let's see. You have a few other one there. And I think, wow, I only have about 3 minutes left. Oh! Now, in the last 3 minutes, let's have some fun. I just recently finished the book called How to Get Ideas, and that is on your extra credit list, your book list. How to Get Ideas, and one of the exercises was. And we only have 2 minutes. One of the exercises was to list 50 uses of a wooden block. So you've got a wooden block that's 2 inches by 2 inches by 2 inches. So, 50 uses of a wooden block. We only have 1 minute. All right, give me a use of a 2 inch by 2 inch by 2 inch block. Robert, go. What did you say? A stand, okay. Oh yeah, you can put something on a little, but you could put a ring on a 2 inch by 2 inch by 2 inch block. You could use it as a ring stand. Okay, Rachel.
Yes?
Yes, we're doing 50 uses of a 2 inch by 2 inch by 2 inch block. We have this 2 inch by 2 inch block of wood. Okay? And we're coming up with 50 uses for this. Robert said a stand, which we could put a little ring on the top of that. Okay? Go ahead.
Maybe a,
You can throw it at the professor so he lets you go out of class. No, that's mine, so you can't use that one. Throw it at the professor. Okay.
Oh, no.
Now you get, Rachel, go for it. Come on now. We got 30 seconds.
Hey, oh man, I know what I'm gonna say. Maybe a table.
Oh, make it what?
Table.
A table for a dollhouse. Very good. There you go. A table for a dollhouse. All right. Shay, you're up to bat.
Put it underneath a gooseneck trailer when you're unhooking it.
Oh, kind of use it to keep something on, kind of like a little, yeah.
So it doesn't sink into the ground.
There you go. So put it, yeah. Well, I was writing with my pen on that. That's good. Oh, yeah. Put it as a wedge or something. There you go. All right. Wyatt, you're next.
A paperweight.
Oh, I like that. A paperweight. Jonte.
Put it as a door stopper.
Doorstop. Good boy. Oh, that's awesome. Courtney.
Put it under a table to make it even.
Oh, yeah. It's kind of a wobbly table. Wobbly table. Make it steady. Well, you got the picture. See, the idea of this problem-solving strategy is just to come up with a whole bunch. And that's all the time we have for today. You guys did awesome.